Welcome to The Explainer. Today, we're going to tackle a pretty huge topic, the end of our world. And I'm not talking about stuff like climate change or asteroids. We're going way, way bigger, to the final, inevitable fate of planet Earth itself.
So what's actually going to happen? To get our heads around this, we've got to zoom out, way out. We're talking about a timeline that isn't measured in centuries, but in billions of years. And this isn't science fiction. It's pieced together from what we know about geology and how stars, like our own sun, evolve over time.
You know, the first big changes that are going to shape our distant future, they're actually happening right now, right under our feet. I'm talking about geological forces. They move so slowly that we can't feel a thing, but give them millions of years and they will completely redraw the map of the world.
So, in what you might call the near future, geologically speaking, of course, our world is going to be totally reshaped by ice and water. For instance, you know that land that was crushed by ancient glaciers? Well, it's still slowly bouncing back, a process called post-glacial rebound. That's going to shrink the Baltic Sea. And Niagara Falls? Yeah, it's going to carve its way right back to Lake Erie and basically disappear. But the real showstopper, the biggest change of all, is this slow, unstoppable dance of the continents, all driven by plate tectonics. Yup, you heard that right. Just like the supercontinent Pangaea that you learned about in school, our continents are on a collision course once again. Geodynamic models are predicting that North and South America are going to slam into Africa and Eurasia, creating this new, absolutely massive landmass. Some scientists are already calling it Pangaea Ultima.
Okay, so while the ground beneath our feet is slowly rearranging itself into a new supercontinent, there's a much bigger, much more powerful clock ticking, and it's about 93 million miles away. Of course, I'm talking about our sun. It's not going to be around forever, and its aging process, well, that's what's going to be the ultimate undoing of our world.
All right, fast forward about 600 million years. The sun is going to be so much brighter that it actually speeds up how rocks erode here on Earth. Now, this is interesting. That process pulls carbon dioxide out of the atmosphere and locks it away in the ground. And the result? CO2 levels are going to drop so low that most plants, the very foundation of most life on this planet, will literally start to suffocate. Okay, let's jump ahead again. 1 billion years from now. At this point, the sun is going to be about 10% brighter than it is today. And that extra heat, that's enough to start boiling away our oceans. This is the beginning of what scientists call a moist greenhouse effect, where just massive amounts of water vapor get forced up into the atmosphere.
Just try to imagine this temperature as the new normal. Once the sun's output is up by about 15.5%, the average temperature in the tropics is going to be a scorching 114 degrees Fahrenheit. That's 47 Celsius. And the poles, our last icy refuge, they'll feel like the tropics do today. Just wow.
So what does all this lead to? The inescapable consequence of our sun aging is that our planet becomes systematically and permanently sterilized. Every single condition that once nurtured life is going to turn against it with really a brutal finality.
Planetary scientist Owen Brian Toon actually painted a really vivid and kind of terrifying picture of what this future moist greenhouse climate would be like. He said it will be like a really unpleasant day in the Sahara Desert, but rainy. I mean, can you picture that? The air is thick with steam. The oceans are evaporating, causing these constant, torrential planet-wide floods. It's a suffocating, scalding, waterlogged apocalypse.
And this is the point of no return. It's called the runaway greenhouse effect. Once the oceans boil away completely, the atmosphere gets so choked with water vapor that it traps an insane amount of heat. Temperatures just spiral out of control. It'll get so hot that the surface of the Earth itself will actually begin to melt. And we're on track to hit that catastrophic tipping point in about 4 billion years.
So here's the crucial point. Even if Earth somehow miraculously survives all that scorching heat, its final, definitive end will come from being swallowed by its own star. See, as the sun runs out of hydrogen fuel, it's going to swell up into a red giant. Its outer layers will expand way beyond our current orbit, and it's going to swallow Mercury, Venus, and us, our entire planet, whole. So faced with total, complete annihilation, is there any way out? Could a hyper-advanced future civilization actually engineer an escape? I know, it sounds like something straight out of science fiction, but some scientists have seriously looked into the physics of this, planetary engineering on a scale that's just mind-boggling.
Yeah, back in 2008,
Two researchers, Mieczysław Talbej and Walter Seifritz, actually argued that survival isn't impossible, at least in theory. The key phrase they used was a thinkable strategy. Now, what they proposed would require technology and energy on a scale that's, well, it's hard to even wrap your head around it. But, and this is the important part, it doesn't actually break the known laws of physics.
Okay, so basically, two big ideas have come out of this. The first one is kind of a temporary fix, something that might buy us another 5 billion years or so. The idea is to build a gigantic screen to block some of the sun's heat. The second idea? Well, that's the permanent solution. An unbelievably ambitious plan to physically move the entire planet Earth to a new home, orbiting a brand new artificial sun. And looking at this really puts the sheer scale of these ideas into perspective. On the left, you've got the sunshade concept, basically a giant parasol parked at a gravitationally stable point to shield us. But on the right, that's the truly radical plan. Physically moving Earth all the way across the solar system to orbit a brand new custom-built star.
So, how in the world would you actually build an art sun? Well, the plan is just an incredible exercise in cosmic engineering. First, you'd have to somehow transport hundreds of Jupiter-sized gas giants from other star systems. Then you'd have to fuse them all together way out in the Kuiper Belt until they ignite and become a new star. You'd even need a massive ring-shaped power station just to keep Earth lit during its 10 million-year journey to its new home. And how do you move the Earth? You'd use asteroids in what's called a swing-by technique, basically using their gravity like a series of slingshots to gently, carefully nudge our entire planet to its new spot. It is just mind-bending to even think about. You know, looking this far into an almost impossibly deep future, it leaves us with a really profound question. We are already engineering our planet today, right? A lot of the time unintentionally. So does that give us the right, or maybe even the responsibility, to one day take full control of its ultimate cosmic destiny? It's a question that really connects what we're doing right now to a future that's almost beyond our imagination.